right, ladies and gentlemen, boys and girls, and people. So this engine is broken. It had 3 bent rods, slightly bent. If you go back one video, you'll be able to see what I found. And here is one of the pistons. This was the only one that was broken. And this one was broken. These 2 rods were bent just ever so slightly to where I actually had to use a straight edge across the deck to see the bend. But what I want to do, because I've had this engine blocked for quite some time and it's been through some shit. I drug it through the mud a few times, not literally, but it's been through some stuff. So what I want to do is I bought a dial bore gauge and I've never used one before. So what you're going to get to see today is this guy try to figure out how to set that thing up and actually use it. So this will be a good video if somebody is new to using a dial bore gauge like me, and I'm going to show you what I'm doing. And if you guys are experienced with the dial bore gauge and you have used one before, leave all your suggestions for improvement or how-to stuff in the comments so I can learn and other people can learn also. That's what we're here for. That's what we do. So let's try to figure this thing out. Dial bore gauge, it's in a box. You gotta open the box. I think what we're gonna do is take this piston. This piston is not in cup holder mode right now. So we're gonna slide this thing down. We're gonna put that in cup holder mode, and then we're gonna slide this right here, and now we can get started. So essentially what this thing is this is a precision tool that's going to be able to measure the diameter, and we'll be able to see it on the gauge in thousandths of an inch. So we'll be able to measure oval for out of round situation and taper. So we'll be able to measure a lot, see if everything is worn excessively, out of round, tapered, or any other issues that are happening with these cylinders. So let's do some things. All right, so I'm going to be using a micrometer, and this is a 4-inch bore. I know it's a 4-inch bore, so I'm going to be using this little rod here that it says 4-inch on it. So what I'm going to do is I'm going to put this thing in. I'm going to take this cap off and put the 4-inch one in there with no spacer. It does come with these spacers, but for now I'm just going to leave this one like this, tighten this thing down, and I'm going to take the gauge and then put the gauge in here. And I did play with this a little bit, but you can see you can move it around and the needle kind of moves. So what I'm going to try to do is set this thing at 0 and 0 at the top, and then I'll tighten it down. So it shouldn't really move. And then what I'm going to want to do is get a 4-inch. I'm going to try to do this so you guys can see it, not me, which might screw me, but so I'm going to get it to about this 4-inch range. And then I'm going to measure the length here. And I'm going to try to get this thing to 4 inches as close as I can. But you can see as I'm squeezing this down and I'm trying to get the micrometer to 4 inches, you can see the needle moving. So here is all the way open at 0, and as I bring it down, that is about 4 inches right there. So I'm about 17 thousandths off. So you can just turn it what the instructions say, is to just turn this thing. So when you get it to 4 inches, or you get it to whatever diameter you need, ooh. So the micrometer is exactly at 4 inches, and the gauge is pretty much zeroed out. So there we go, 4 inches. It's at 4 inches, and micrometer zeroed. So essentially what you want to do is take the micrometer, verify this measurement, and make sure that the gauge is lined up on 0. It's a little bit tricky, and the instructions say to just turn the gauge to wherever the needle goes. So get this thing set, micrometer set on 4 inches, or whatever diameter you want, and then turn this thing to wherever the needle is. But I think what I'm going to do is set the height, because you can change the needle movement with the height of the gauge. So I think what I want to do is line that up so the needle height is right at the top at 4 inches. You can see we're right at 4 inches, and gauge is set right at 0. It is fluctuating a little bit back and forth between 999 and 4, but we're gonna call it, and it's just kind of sitting there, so it's probably shifting a little bit. Okay, so we got this thing set up. It's calibrated at 4 inches, and I'm gonna stuff it in the bore, and you can see I'm basically gonna find the smallest point when it's closest to 0. It's about as high as it's gonna go. So that's right at 4 inches. So this part in the bore is right at 4 inches, which is the factory spec. So I'm gonna start to move this down, and I'm just always gonna try to keep it at the highest point. See, as I rock it back and forth, it goes higher and then comes back down. So I'm gonna keep this thing kind of at the highest point. You can see it's like about 1/1000th of an inch. It's actually tighter. So this is at like 3.999. About 1/1000th of an inch smaller than the factory spec, all the way down. So we'll move over. I'm gonna do number 5. It's actually the one that was broken. Same thing, we're right at 4 inches. Just gonna go down and kind of see where it goes. So this is actually showing like smaller than factory. 3.999, 3.998. Move over. We'll do number 3. It's pretty much the same thing all the way down, but they're pretty consistent. I'm gonna verify that this is still at 4 inches because I turned it. I turned the gauge so the camera could see it. So I just want to verify that this thing is actually still at 4. Yeah, it's pretty much right at 4. It did shift a little bit, but less than 1/1000th. So there. So that'll make up for what it shifted when I turned it. So we see this one. It's right at 4. It's pretty much right at 4. All the way down. It does get a little smaller. It goes to like the 3.999. Number 5 is pretty much the same thing, like right at 4, all the way down. Number 3. No matter where I put it, it's like 3.999 is the smallest dimension, and they're within 1,000th. Both dimensions, all the way down in every cylinder, are within 1,000th. And at the, I would say the widest point, like 2,000ths off. So I would say that's actually pretty good. All right, so let's gather our thoughts and try to formulate a sentence here. So the bores all, in my opinion, checked out okay. They were all within 1,000th of the manufacturer spec. But there's also another spec, the piston to bore clearance. So these, from what I found, are 28 thousandths. Just from what I found Googlifying and searching around, that the piston to bore clearance is supposed to be not 28 thousandths. It's supposed to be like 2 thousandths or 2.8 thousandths. So when I measure across the skirt, it's measuring at like 3.995. So I believe that's out of spec for what the manufacturer says. That's probably negligible. I mean, it's a couple of thousandths of an inch off, but that may be why, you know, we're causing some piston to rattle around a little bit. So this one was actually a little bit bigger. This one was like 3 thousandths off instead of 2 thousandths. So 2 thousandths smaller than the bore. So that one was closer than this one. So this one was the farthest off. This one was about 4 to 5 thousandths smaller than the bore. So I think that's out of spec, but I'm sure there's guys running it like that all the time and not having any issues. So just wanted to do that. My main thing I wanted to check, I mean, the pistons are already junk anyways and the rods are bent, so those are going to go, but I did want to check the bore. I don't actually think that anything is wrong with the bores. So from what I've seen, they all seem like they're round. There is maybe like a thousandth of an inch of taper. I'm not really sure what the taper spec is. I'd have to look that up yet. If you guys know, leave it in the comments. But I feel like the bore is okay, so not really sure if I need to do much with that. Just get some different pistons for it. And I will add, for those that don't know, this is like a 340,000 mile block. So I bought this block, this engine, originally for $200 on Craigslist. It was a low oil pressure engine. I rebuilt it. I'm still using the factory oil pump that came with the low oil pressure engine. It ended up being a spun cam bearing. That was the cause of the low oil pressure. Put new cam bearings in it, and this is where we're at. So the bore seems like it's fine, and this is a like 340,000 mile engine. So if that says anything, pistons and everything still seem like they're pretty much inside the serviceable range at 340,000 miles. Yeah.